In this video, we will learn about the general equilibrium analysis. Before we go for the general equilibrium, let's understand what is the difference between partial equilibrium and what we want to learn, that is general equilibrium. Okay, so this partial equilibrium was given by Alfred Marshall, and we also call this Marshallian equilibrium. Okay, and it simply means when we determine the equilibrium of a single product or a single market, keeping every else constant, what we call the ceteris paribus. Okay, if we have, let us say, single product or a single market, okay, here we would have some price and we have some quantity, and here we trace the relationship between quantity demanded and price, and we keep all other factors fixed, what we call ceteris paribus. Okay, when we trace this relationship for a good or a single market, keeping all other factors constant, we are talking about the partial equilibrium. Okay, so we don't sorry we actually study a single market in an isolated manner, and this is the called the partial equilibrium. And what about general equilibrium? Now, in general equilibrium, we study how demand and supply interact in several markets to obtain, equilibrium price of several goods. Okay, so there is not, isolated market. Markets are interconnected. So to explain this, let's take an example. Okay, let us say we have a market for electric cars. Okay, so we have this electric car. Okay, to make this car, okay, let us say this market, or rather this market is getting the tires for this this electric car for another market, what we call, let us say this is tire market. Okay, and to make tires, okay, we need steel. Let us say we have another market here, what we call steel market. Okay, steel market. Now, if the price of electric car increases, quantity demanded of electric vehicle will decrease. Okay, then what will happen? If the quantity demanded of electric vehicle is decreased, that means the demand of tires will also decrease. Okay, so the equilibrium in this market will influence this tire market where tires are being produced. Okay, since quantity demanded of electric vehicles has decreased, the demand for tires has been decreased, and obviously we mean that this car is being assembled. So this electric car company or firm does not make tires by itself. It actually gets it from another market. So quantity demanded of electric cars, if it gets decreased, the tires sorry the the quantity supplied in this market will also get decreased in tire market. Okay, and obviously since to make the tires we need the steel, so this will affect this steel market also, and this all stuff will re-influence this market again. Okay, so this is a kind of general equilibrium where we study how demand and supply interact in several markets to obtain equilibrium pricing of several goods. Okay, so we don't study the markets in an isolated manner or in an independent manner. Okay, in partial, what we do, we hold everything else constant and trace the relationship between price of a good and quantity demanded of good. But in general equilibrium, we study, or it explains how supply and demand in an economy with many markets interact dynamically and culminate into an equilibrium. Okay, so this is the difference between partial and general. In partial, we hold other factors or other markets constant and trace the relationship between price of a good and the quantity as demanded, or demand for good and supply of good, and we don't assume that other markets will influence this market, or its demand and supply will influence other market. But in general equilibrium, you know we study how demand and supply interact in several markets to obtain equilibrium prices of several goods. Okay, now let's learn about some of the assumptions of the general equilibrium analysis. So first is multiple goods are traded, bought and sold, obviously. Okay, we have perfect competition in this economy. By perfect competition, we mean in the sense that everyone is a price taker. Okay, this is purely an exchange economy, purely exchange economy. So we have here barter system, and no production is allowed. Okay, so the consumers, or rather the persons, just exchange what they have. Okay, so they simply exchange. There is no production in this economy. And we take a simplest case of, two-person, two good economy. Okay, so we take two persons or two agents, two good economy to explain the general equilibrium analysis. Okay, so we could have, number of we could have taken, n number of persons, but it will complicate the things, obviously. So we are just giving the simplest case of two persons. Let us say we have two persons, A and B are the two persons, and the two goods in the economy are, let us say, good 1 and good 2. Okay, now let's define the initial endowment. Okay, so initial endowment. Okay, so we have two persons, person 1, person B. Let us say this is person A, person B. Initial endowments, let's denote initial endowments by WA is equal to WA1. Now what does this mean? Initial endowment for person A means that how many units of good 1 the person A has initially. Okay, comma, WA2. This denotes how many units of good 2 does the person A has initially. Okay, similarly, for second person, what we call the person B, WB denotes the initial endowment of person B, and it can also be shown like this: WB1, comma, WB2. This shows the initial endowment, how many units of good 1 and 2 both persons have initially before they trade. Okay, before they exchange. Okay, now every bundle in this economy is called allocation. Okay, so what, let me write it here: allocation is every bundle, every bundle in the economy. Okay, in economy, I'm just writing it loosely, so it cannot be, perfectly all right for definition purposes. Okay, so every bundle in the economy is called an allocation. And how do we show the allocation? So let's write me here like this: X A and XB. So XA is simply, XA denotes units of A, sorry, let me, number of units that A is consuming. Similarly, we have X2A, okay, units of good 2 for consumer A or person A. So this XA is the vector of these two terms. Similarly, we have for XB, we have XB1, okay, units of good 1 for consumer B. and XB to units of good 2 for consumer B. This shows us an allocation, and I will explain it, in this video, where we will require this kind of allocation. I will explain there what exactly does it mean. And by the way, if we solve a numerical, which I will inshallah, so you will get all the idea. It's not a rocket science to learn about this general equilibrium. It's actually very simple. Okay, so this is an allocation. Now what we want to know, rather what we need to learn, is about the feasible allocation. Okay, so what is feasible? What is meant by feasible allocation? Feasible allocation, we say an allocation is feasible, okay, if let me write it here. We say if allocation sorry an allocation is feasible if x a 1 plus x b 1. Okay, this shows the composite demand of good 1 by person A and B. Okay, total demand of good 1 by person A and B, it should be equal to W A1 plus W B1. Okay, this denotes the total endowment of good 1. Initially, the person say, I am just getting, you know, asking about the consumers. This shows the you know, total demand of good 1 by two persons or two agents. Okay, so this shows total demand of good 1 by person A and B. This shows the total supply of good 1 by person A and B, and this they should be equal. Okay, so why is there this equality sign? Okay, we could have had this kind of inequality. Okay, so this inequality, okay, does not hold here. Why? Because we are, assuming that persons are having some initial endowments. They have something with them. If this inequality holds, then what does this mean? It simply means demand for good 1, okay? Demand for good 1 is greater than supply of good 1. It is not possible because we have supply fixed. There is no production possible. Okay, so it is very logically correct that here demand cannot be greater than supply. Okay, let us say we have uh, 2 units of apples, 3 units of banana. Then let us say this is the demand. Okay, if we have supply, let us say only 1 unit of apple and 2 units of banana. Okay, you can simply see here the demand is greater than supply, but this is not possible because initially the consumer is having only 1 unit of apple and 2 units of banana. Simple thing, this inequality does not make any sense here. Similarly, what if we have this demand is less than supply? Okay, this can be a reasonable thing, but so total demand of good 1 can be less than total supply of good 1. But it may make sense at times. But what we are assuming here also, we are assuming that more is okay, more is good than less, good than less. Okay, so more of more of the goods is very nice thing than having less of the two goods. Okay, so more is good than less. Demand can be less than supply, but this will not make any sense if we are assuming more is preferable than less. Okay, so the only thing which is being left is that they should be equal. That means demand for good 1 by person A and B should be equal to the initial endowments of the good 1 held by person A and B. That means demand, composite demand should be equal to the supply. So WA1 plus WB1 denotes the supply of the good 1. Okay, symmetrically we will have let me see if I have space. Yes, I do have. So X na lagun pen tishna gasa hokani this kalas. So X, you know, XA2 denotes, units of good 2 by A by person A plus XB2 should be equal to WA2 plus WB2. Okay, composite demand of good 2 by 2 persons A and B should be equal to the total supply of good 2 being supplied by person A and person B. Okay, so then the allocation is feasible. Okay, now we will go to we will learn about the Edgeworth box. Okay, so by Edgeworth box, what we mean, Edgeworth box is a graphical tool which depicts the endowments and preferences of two agents. Okay, so this simply shows us the endowments and preferences of the two agents, what we call the Edgeworth box. Okay, so first we will see how to interpret an Edgeworth box. Let me draw the Edgeworth box here. Okay, so let's draw the Edgeworth box. I hope I'm making myself clear. So we have this rectangle kind of shape. Here this point shows the origin of person A, OA. This shows the initial endowment here of person A, or origin of person A simply. And this shows the origin of person B. Okay. Now the width, this green line, this width shows us the total supply of good 1. So first let me write it here. This shows us good 1, good 1. Okay, on this axis we denote the good 1. Here we show good 2, good 2. Okay, now the width of this rectangle shows us the total endowments of good 1. That means it shows us WA1 plus WB1. Okay, so the width of this box shows us the total supply of good 1, and similarly height of this Edgeworth box shows us this, the height of this shows us the endowment of good 2. Okay, so supply of good 2, so this is WA2 plus WB2. Okay, so this shows the total supply of good 2. So this red line shows us the total supply of good 2. This green line shows the total supply of good 1. Okay, now let's take any point inside this rectangular box. Let's take any point. Let us say we have this point. Okay, now if we have this point, we say this point is an allocation. Obviously it is an feasible allocation. And how do we interpret this point? This point will show us, so let me draw it something like this. This point A shows, it shows us let me draw it here. It shows units of good 1. So let me write it here like this. X A1. Okay, so this shows the units of good 1 consumed by person A, this point, okay? And corresponding to this, up to this shows the units of good 2 consumed by person A, obviously, okay? Now, what about this person B? So let us draw it here, something like this. So this shows up to this, it shows units of good, so let me write it here. So this shows us units of good, so on this axis we are measuring good 2, units of good 2 held by person B, and this will show us up to this, because we are dealing with this point, it will show us units of good 1 held by person B, okay? So this is how do we form the Edgeworth box, okay? I'm not talking about the preferences here, okay? So it will get then, I don't have the space to make the preferences also here. Now you can easily see here WA1 plus WB1, okay, is equal to XA1 plus XB1 here, okay? So if this green line denotes WA1 plus WB1, then these two red lines shows us XA1 plus XB1. So obviously here they are equal, okay? So we have XA1 plus XB1. It shows total supply, okay? So this W, WA1 plus WB1 shows us the total supply, okay? Up to this we have the total supply of good 1. It is actually equal to the total demand of good 1, okay? So we have good 1, up to this we are consuming XA1 units from this point, okay? Corresponding to this we have good 1 here, which is being consumed by consumer B. So here total supply is actually equal to total demand, and corresponding to this you can see here also. So total endowment on this axis we have W, so let me use another color. So we have WA2 plus WB2 total supply. So this red line shows us the total supply of good 2 is equal to total demand of good 2. So from this, because we are taking about this position, so here we have XA2 demand of good 2 by person A, plus here we have XB2. Here you can also see you know supply is equal to demand. So any point in this box is actually a feasible allocation. By feasible allocation, what we mean, the demand of the two goods is exactly equal to the initial endowments that the two persons have brought, or simply demand is equal to supply, okay? Now let me show the Pareto improvement. What is meant by Pareto improvement? So can I show it here?